All right, you guys, we're now going to talk about two other shortcuts that if you can show just three corresponding congruent parts in one triangle or congruent to just three corresponding congruent angle or side parts in another triangle, you can show triangles are congruent. So some of these work, some of these combinations do not work, so we have to be careful. Okay, so the next postulate we're going to talk about is the angle side angle postulate, or the ASA postulate. Okay, so what this says, if you have an angle, and then you have a side, and then you have an angle that is congruent in the same manner in a different triangle, that is enough information to show that your two triangles are congruent, which is pretty cool. Okay, so kind of like the SAS postulate, the angle lied between the two sides. In the ASA postulate, it's very similar, just the reverse. So this time we have two angles with a side marked congruent right in between them. So angle, then a side, then an angle. So if you can show two angles with a side in between them are congruent in the same manner in a different triangle, that is enough information to show triangles are congruent. So it's another one of our shortcuts, which is pretty cool. The final shortcut that works if you compare three parts of in one triangle to three parts in another triangle and they happen to be congruent is the angle side postulate, or the AAS postulate. Okay, so it's kind of like the angle side angle. So angle side angle, you have two angles with a side marked in between them. Angle side, you have two angles marked congruent, and then the side that is congruent is not in between the angles. So this one is kind of the reverse of SSA, which SSA does not work, so be careful. Okay, so the two angles are side by side, and then the side is not in between the two angles. So angle, then side, versus angle, then side, then angle. So take it in, make sure you understand the difference. Okay. Now we're going to talk about the two postulates that do not work, which we've already talked about one of them already. The one we've already talked about is the side angle postulate, which remember, it spells a bad word. So we don't say bad words in math. So first of all, this postulate would never work to begin with, but it also doesn't work because if you have two sides and an angle that is not in between the two sides that are congruent, you can make a completely different triangle with those same two sides and same angle. Like these two triangles have two sides, two corresponding sides that are congruent, and an angle that's congruent, but they are two completely different triangles. So like remember, if you kind of use this side and swing it out, you can make a completely different triangle. Okay, so this angle up top changed, but that's not one of the congruent angles, or the parts that's supposed to stay congruent. So side angle epically fails, and it spells a bad word, so obviously it's not going to work. The other postulate that will not work is the angle postulate, the AAA, AAA. It does not work. Okay, if you have two triangles that contain the same angle measures, the triangles could be different sizes because if you think about an angle, you can keep extending the rays of the angle, and then the sides of the triangle could keep getting larger or smaller. So the angle size could stay the same. Like this angle, it starts going and it stops here, starts going and stops here. This is the same exact angle as angle A, but the rays continue on a little bit further, which makes the sides of the triangle bigger. Guys, so when you have two shapes that are the same shape, but different sizes, if you think back to transformations, this is called a dilation. And later on, we're going to talk about how these are also referred to as similar triangles, which have different characteristics than congruent triangles. So, be careful. AAA, although AAA is great at helping you when your car breaks down, AAA will not save you when you're trying to prove triangles are congruent. So let's avoid AAA and the SSA postulate. Not allowed. Okay, so now what we're going to do, example 9 through 12, these are very similar to example 1 through 4, except this time we're trying to show the triangles are congruent by ASA and AAS. Okay, so we're trying to use our two new shortcuts to prove triangles are congruent. Okay, you guys, let's get going on example 9. I'm super excited. again, I have the triangles all lined up for us so we can kind of see them in one place. So the 4 shortcuts that work are SSS, ASA, SAS, and AAS. So take it in. These are the 4 shortcuts that do show triangles are congruent and is enough information to show triangles are congruent. The 2 that do not work and cause fire-breathing demon cats are SSA and AAA. So just watch yourself. These work. These don't. These work. These don't. So be careful. Okay, now let's get started on example 9. I promise I'm not lying to you this time. Okay, so again, we're going to state if the 2 triangles are congruent, and if they are, we're going to state how they know. And this time we're focusing in on the ASA postulate and AAS. So again, ASA, 2 angles marked congruent with the side in between them, and angle side, we have 2 congruent angles with the side marked that is not in between them. So these are the 2 we're focusing on right now. Okay, let's get going, you guys. So again, when we get started, I'm going to mark everything in my picture that is already given to me. And this one is not named. So just to make sense of the segments and angles, I'm going to name my triangle. Let's see, what's a nice 4-letter word? I'm going to say pause is a great 4-letter word, pause. Like cat paws, right? Okay, so let's go ahead and state the parts of the triangle that are already given to us. Okay, let's see here. So far I spot 2 congruent angles, and I actually see 2 pairs of congruent angles. The first one I see are these 2 angles right here. Whoa. Okay, so I know angle WAS is congruent to WAS is congruent to ASP. So angle WAS, the WAS angle, is congruent to the ASP angle, the ASP. Okay, I'm trying to sound out the words, but you know, that's not a word, so I kind of failed. But anyway, so again, the reason why I know they're congruent is because it's given to me. It was given. Okay, I also know that 2 other angles are congruent, but remember, these are the tricky ones. These 2 are not congruent marks. What do these little box things mean? They do mean right angles, and right angles are always 90 degrees, which means we do know that right angles are congruent. So I can say that angle WSA, angle W to the S to the A, is congruent to angle PAS. Oh, I need an angle. Angle PAS. And this time it's not necessarily because it was given. What was given to me was the fact that they were 90-degree angles. Okay, so on this one, you guys, we know that right angles are congruent because they're all 90 degrees. So this one's not a given. This one's going to be all right angles are congruent. All right angles are congruent. And I'm kind of out of space. I'll squeeze it in down here. Okay, here we go. All right angles are congruent. Okay, so I currently don't know which route I'm going. Angle side and angle side angle both contain 2 angles. And currently I have 2 angles listed as congruent. So I don't know. I'm kind of excited to see where this takes me. Okay, so since nothing else is given to me, I'm looking for one of those tricks up my sleeves to mark an additional part of my triangle congruent. Do you guys see either vertical angles, the X? Do you see a shared side or shared angle, the reflexive property? Or do you see that 2 angles are congruent, which means the third angles are congruent? Well, actually, you guys, we have 2 of those tricks up our sleeves. So I'm going to talk about one of them first, which will show that the triangles are congruent in one way. And then this star down here, this is like an extra bonus. Technically, I can use another trick up my sleeve to show that the triangles are congruent in another way. Whoa, I got so excited I dropped my pen. We can show these 2 triangles are congruent in 2 ways, which is like really awesome. Like the holiest of all hot dogs, okay? Okay, so I'm going to start with the reflexive side. Do you guys see how this side, side AS, is in the top triangle and the bottom triangle? So I can say AS is congruent to itself by the reflexive property. Okay, so I already know that side is congruent by the reflexive property. And guess what, you guys? After I mark in that side, the triangles are already congruent. Okay, so again, it's all about where is that side placed. If the side is in between two congruent angles, it's ASA. If the side is not in between the two angles, it's angle, angle, side. So let's see. You start from your outermost corners or outermost markings, and then you kind of go around the triangle, but you can't skip more than one unmarked side or angle. Like if I go this way, I have an unmarked side and an unmarked angle and an unmarked side. That's too many unmarked pieces. So I have to go the other way. So if you guys see here, I see an angle, then a side, then an angle. And in the top one, I see an angle, then a side, then an angle. Or I see two angles with a side in between them. So guess what, you guys? Both of the triangles are congruent by ASA. So I can already write my triangle congruency statement, which is pretty cool. I can say triangle, let's see here. I'm going to call the first one triangle was. So triangle was is congruent to triangle. Now remember, you got to write in a very special way because all the parts in this statement must be corresponding or relate to the other letters in this triangle. Okay, so W doesn't have any angle markings. So this one has 0 angle markings. A has one little arc. And the S, it does kind of have one little arc, but it's like the right angle. So I'm going to put this for the right angle. Okay, so I have 0 marks, then I have one arc, and then I have a right angle. So the little L, right angles make like an L shape, right? Not that you're a loser. You're definitely not a loser, but that's kind of the shape a right angle makes. Okay, so I need 0 marks on my angle, then I need one arc on my angle, and then I need a right angle. So that's kind of what I'm looking for. Okay, so I see here, this angle doesn't have any marking, so I know that has to be the first one. So it's going to be P, and then which angle has one marking and is not a right angle? Well, that would be the S. So P, then S, then the right angle, which is A. So PSA. A public service announcement. Look at that. Okay, and we already know they're congruent by by the ASA postulate. Yay! Now, but we could stop here and be done with the problem, but we are overachievers. We like to show in as many ways as possible how these two triangles are congruent, okay? So I want to bring in another trick in my sleeve to show that the triangles are also congruent in a third or in a second way, which is really cool. Okay, so I don't have vertical angles, so I can't use vertical angles. I already used the reflexive property, but I can also use the third angle theorem. I know that two angles in my triangle are congruent, which means the third angle has to be congruent by the third angle theorem. Okay, so I'm going to say my third angle, or my final angles, angle P is congruent to angle W. So angle P is congruent to angle W by the third angle theorem. Third angle theorem. Okay. And now looking at my triangle, so I see they're still congruent by ASA, but also they're congruent by angle, angle, side. Okay, so the first time I'm going to show you by ignoring the right angle. If you guys see in the top triangle, I have two angles and a side, not marked between them, or an angle. If I trace around my triangle, angle, then side. Or I could go the other way. I could go like this. I could ignore this angle and see I have an angle, then a side. So angle, angle, side. So I can get angle, angle, side either way. And same down here. I have an angle, then side. Or I could go the other way, an angle, then side. And it's okay to go this way because I'm only skipping one side that is not marked. So angle, angle, side. So they're also congruent by, and angle, angle, side. And that was so exciting. I'm going to draw a cat because it's not very often you can prove triangles are congruent in more than one way. So nice job, you guys. We have tackled our first example using the ASA and AAS properties. So now we're moving on to example 10, which is going to be just as fun. So hold your horses. We'll be starting on example 10 momentarily. Nice job, you guys.